Okay, hello, and welcome to my channel. Today we're gonna talk about uncertainty in quantum mechanics. So let's first start with, well, a more familiar term for uncertainty, which is variance in statistics. And I think that most of you would have heard of this term before. So let's start from statistic here. So for example, you have an arbitrary Q value here for arbitrary Q. You would get the mean for Q, which is the sum, right? Would be the sum Qi. Oh shit. Qi. Okay, better use P, but whatever. Just take this like this. That is the definition for the mean value, right? And as you know, the variance squared is, well, the variance squared is equal to the the mean of Q squared minus the mean of Q squared. And this is greater or equal to 0. That is another definition here. Nothing much. And your if your variance here is equal to 0, your mean would be equal to your Qi, meaning there are absolutely no spread. So you get that it is deterministic, no spread, so this satisfied. And let's move on to quantum mechanics here. So let's first consider a Hermitian operator Q hat. So we're gonna move to quantum mechanics. Consider you get a Hermitian Q hat. The definition for uncertainty is kind of the same for as this one here. It would be the uncertainty square would equal to the expectation value of Q squared minus the expectation value of Q squared. So one way to remember this is that you would imagine the two jumping out. That is, well, my way to remember this thing. And I believe we have some more way to write this. So you can also write this as this. Oh my gosh. Where and one more way is like this. Dx minus q squared. I believe that is one more way to write it. Okay, I'm wrong. We would need like a psi here. That would something like that. Right. And here when you consider the uncertainty, and if in like example you get like your psi is an eigenstate of q, then, well, as you remember, I told you before, q on psi would equal to a number times psi, and another thing is that q psi would equal to the expectation value on psi. Okay, so what you would get from this is you group these two together and they would be equal to 1. So that means 0. What am I saying? It's weird these days. Equal to 0, and therefore this part is equal to 0. And what is this part? This part is your uncertainty. So the uncertainty in psi, if psi is an eigenstate, is 0. Right, so this is pretty brief because there's nothing to talk much about this part. It is most of the time pretty easy when you encounter them in problem sets, or when you get questions about definitions. There are nothing much to talk about. Alright, so that's it for today. Goodbye.